A warm welcome to the Dietz Conference 2022. My name is Marco Dietz. I am the responsible product manager for LoRaWAN at Thermokon. And today we want to talk about IoT-ready building automation. We want to show an approach how LoRaWAN could empower traditional wired building automation systems. First of all, what could you expect within the next 20 minutes? First of all, we want to talk about what traditional building automation is. Then short show what Thermokon's role inside this ecosystem is, and then give some business insights. At last, we want to come to the most important point and show how LoRaWAN could empower this traditional building automation. This year, the Dietz conference is under the topic of digital transformation, and we found a perfect fitting statement about digital transformation. And this says that digital transformation is about using structures of yesterday with the methods of today to solve challenges of tomorrow. And we want to show you how this could be possible in a traditional building automation. That's why we want to take you along a short trip through the traditional building automation market and technologies. First of all, we have to talk about the difference between building automation and home automation. If you're talking about building automation, you're talking about larger project scope than in home automation. That is the main difference between both. The technology could be the same, but the project scope is different. Also, the users, if you're talking about buildings, we have various undefined users, and a home is mostly used by the owner itself. Also, the implementation is different, as building automation is mostly done by system integrators and not by do-it-yourself enthusiasts. And the main focus for building automation is to reduce the operational costs for the owner, and home automation is also more focusing on comfort and entertainment aspects. This distinction is not absolute, it's just exemplary and should give an indication of what we are talking about now. We now want to talk more about the left side, about the building automation. During the last years, the building automation had made a development. In the beginning, there was the traditional manual operated building. This building is just so smart as the operator itself. Then more and more automation comes into a building. That means we have rule-based actuators that could do some actions like light or radiator controls. In the future, there's more about a smart and totally connected buildings that also includes perhaps online data for controlling a building. Even if a smart building is today possible, we also have many manual operated buildings in the field. And even if these manual buildings are still automated, they are not always smart. Just to give an example, if you have included a central shutdown command at the end of the day and don't take into account the occupancy state of the building, then this is not very smart. But why is the smart building now the overall goal? I guess it's quite obvious. Many of us are spending 80 to 90% of our daytime in a building, and so the indoor air quality is very important for the health and the well-being of the users itself, and also is the building sector reliable for about 1/3 of the worldwide CO2 emissions. And if the building sector won't contribute its part to the emissions reduction, then we need more smart buildings. If we are talking about building automation, we are mainly talking about light control, blind control, and climate control. Climate control is everything related to heating, ventilation, and air conditioning. It's clear that there are more disciplines inside a building. For example, the entrance control, the water supply, or fire protection. But these three parts, climate, light, and blinds, are the main originators of building emissions and most important for indoor air quality. So that's the reason why we are focusing now mostly on these three parts. How does a traditional building automation system looks like? It's typically hierarchical. It means you have a kind of automation pyramid. At the basement, you have the field devices like sensors and actuators in the field. These sensors and actuators are connected with the automation layer where the logical connection of these is done. And these automation controllers are then connected to the control layer where you have a kind of supervision system about the different automation stations and field devices that act as a kind of central control center. Thermokon's part inside this ecosystem is now since 35 years at the field layer. We are producing devices that measures nearly everything that's necessary for automated building, and also producing input devices to give user inputs from the field layer to the automation layer. If you're talking about these layers, it's become obvious that we need standardized interfaces that these different layers could communicate with each other. And there are many different out in the fields. Just to give a short overview about this, in the beginning, there were just the easy digital and analog outputs. Simplest way of control something, just switch it on and off, like a relay output. And the easiness and the simplicity is also the biggest advantage. You don't need any specialists for installation, and the principle of this communication system is nearly clear to everyone. Even if they are, let me say, old, they are widely used in the field. They're still widely used in the field, and or even in new projects used, not only for retrofit or in old buildings, also for new projects. The next part of communication systems are the more advanced one, that are wired bus systems. These bus systems are used if you have to transmit more complex data. Every of these bus systems has its own advantages and has become a kind of standard in the typical application type. For example, DALI is a typical bus system for Lightning applications, and BACnet is a very common used bus protocol in HVAC application. That means all applications that are related to heating, ventilation, and air conditioning. The third big part of field communication systems are the wireless systems. They are also focusing on different applications. If you need energy self-sufficient radio protocols, then you have to choose for an ocean. If you have a demand for higher data rates, then Wi-Fi is perfect. And if you need a long transmission range, then LoRaWAN comes into the game. If you now get this overview about the different field communication systems, it becomes more clear that in building automation, nearly everything is about system interconnection. That means it's very important how the different systems could communicate with each other, as it is very hardly possible to find a field communication system that covers all requirements. as the requirements in building automation are very different. It means there are many questions that have to be clear before choosing a right communication system. Just to give a few examples, are we talking about a retrofit project, or is it a new construction? Should use an open communication standard be used, or is a vendor lock-in no problem? Is in general a wireless communication system possible or not? And these questions have to be answered before choosing the communication protocol. Just to give an example, if you're talking about different application types, there are some application types they need a low latency time. For example, soft real-time requirements for light control. As in the building automation, everything below 200 milliseconds is seen as real-time. It means you switch on the button and the light switches on immediately. And if you need if you have these requirements, then for example, an event-driven wired bus system like KNX or a wireless system with a low latency time is like an ocean, is perfectly suited. If you have applications with a higher latency time, like time uncritical applications, e.g. heating, there it doesn't matter if the heating switches on 1 second earlier or later. Then also a little bit slower cyclic polling bus system like Modbus, or duty cycle restricted radio protocol like LoRaWAN has its advantages. Within a building, there are also other systems than the control systems. One big part is still the IT system, and both of these systems in reality oftentimes exist next to each other. Oftentimes they are independent, and as they are independent from each other, they have different responsibilities. And one is the system integrator for the control system, and the other hand is the IT administrator. And oftentimes these systems are strictly locked, and it's hardly possible to get access to the system and use this communication infrastructure. This leads to some curiosities as shown on the right-hand side. An example where two occupancy and two smoke sensors were installed on exactly the same position, but the data were forwarded to different systems. It means one perhaps is for the lighting control and one is for the climate control, or one is for the IT system. So oftentimes this shows that these different systems in the building causes some curiosities. And perhaps you see now that the issue that is occurring if we are talking about LoRaWAN. LoRaWAN traditionally comes out of the IT system, and in buildings, the building automation control is often done by control system. And now we have to find a way how we could bring together both systems. In building automation, there are also some other topics we have to talk about if you want to understand the market and how this project works. In building automation, there are very systematic and complex planning and tender procedures. That means there are many participants along the chain, everybody with its own opinion, and sometimes this makes projects seem slow. And if you want to bring a new technology into such a system, then you have to convince many participants and not just one person or one party. On the other side, you have divided ecosystems on site also. That means if you want to install a system that belongs to different ecosystems like the IT or the control system, then it could cause some struggles on site directly. The third point is the business models many buildings are operated with. Some or many buildings are operated on data point business models. That means the system integrator charges for the amount of data points included. And so the system layout is chosen due to the minimum amount of data points and is not bringing out its full potential. So oftentimes the buildings have good working automations, but are not really smart. The fourth big point is that you have a very high stock of existing buildings that are using traditional wired communication systems. And if a new technology wants to be successful within the building section, then you can't ignore this. Now I want to show the transformation approach that we have developed and show how we can bring together the different worlds. We decided for implementing LoRaWAN at the field layer and not put a sophisticated IoT framework at the control layer. And now we want to explain how we have done this implementation and why we have done this at the field layer. Here you see a typically Modbus building management system. On the upper part, you have the control and the automation layer, and then connected the different field devices. You have a room operating unit that is connected via a Modbus bus system directly and gives its inputs directly to the building management system. The building management system itself then controls the climate, the heating, cooling, and ventilation actuators, controls the light, and controls the blind. Now we are adding the LoRaWAN connectivity to this system. That means we have now immediately the possibility to monitor the whole room status. That means we have all important informations like sensor values that are included in the room operating unit, and also have the actual status of the climate control, the light control, and the blind control. On the other hand side, if we are going the way back from an IoT portal like DataCake through a network server like the Sync Stack to our existing system, we can realize our override functionalities. That means we can control the room out of the cloud. But the existing building management system stays as it is. That means you don't have to change the components. There we don't have to allow access to the building management system directly. You're just adding the LoRaWAN functionality, and the whole setup on the building management side could stay as it is. Hopefully, this shows now how the different systems, like the IT system and the control system, could be brought together. And they are brought together in the room operating unit, and we have chosen this room operating unit to implement the LoRaWAN, as we see this as a central element of a room or building automation. That means this is the point where user inputs are done, and where you can fetch the most important data of a room, like sensor values and room control functionalities directly. Also, if you have the possibility to override this system, you have the possibility to override the whole room. If this room operating unit is used, you also have a familiar user interface. And this is very important for building automation, as we had heard before that you have various users there. And so you need a user interface that can be overridden by everyone in the room. If we are talking about on-site control, then you have low latency times in controlling the blind or light, and it's very comfortable for a user itself. But on the other hand, you have these IoT-based services, and you can put overriding functionalities down to the systems, or could fetch the sensor data out of the system and enable cloud-based services like dashboards or AI optimization or something like this. And as I said before, one of the most important parts from our point of view is that the existing structures can stay as it is, and you just combining instead of replacing, as removing a working system and replacing it by another is not very green and very smart. Yeah, as shown before, there are many communication systems in a building, and we have shown the approach for a traditional wired system, but this approach is also possible for a wireless system. In building automation, an ocean system is very common used, and oftentimes in single room automation applications. That means we have a wireless room application and the whole control is done inside the room. You have one single controller and this interacts directly with the actuators like a radiator valve, a blind control or light control. And we now implementing a LoRaWAN connectivity through this by just grabbing the data that are necessary for monitoring and overriding functionalities, and also just sending back the important data and let the low latency radio traffic inside the room and just using LoRaWAN for connectivity to the cloud. This wireless solution with an ocean and LoRaWAN is also perfect fitted for typical retrofit applications. Yeah, now referring back to the slogan and the statement we had before, I hope that this keynote made clear how the structures of yesterday could be empowered with the potential LoRaWAN is offering at the moment. And I guess every one of you agrees that there are many challenges. Also the building sector has to deal with if we want to have our planet green and save the resources that we still have. So from my side, then many thanks for your attention. If you have any questions, please feel free to reach me via mail or via LinkedIn. And I would also looking forward to discuss with you different possibilities our approach can provide to you and your solutions. Many thanks.